that. Okay. So now just try to go through whatever he had given. Okay, so with going with the syllabus, it's almost done. So just go with that YouTube link and see if anything you feel that important, or if anything you want which I had missed, you just tell me. I mean, you can just message me. Okay, so that we will see to that on Monday. Okay, so then I'll talk about the project thing to sir, and I will let you know, okay, what you are supposed to do. Okay, and I think most of you are good at Python, because I received some of the mails. But okay, but because I have exam till, I mean, next week also I have an exam. So this weekend, if possible, I will get back to you. If not possible, anyways, by next Wednesday or something, it will get over. So within next weekend, I will get get back with all the mails whichever you have sent. Okay, so please be patient. Okay, so now I'll just go with the classes. So now dimensionality reduction, all of you got it right. So did you all check with that eigenvalues, eigenvector, correlation, covariance? I'm not getting any response from you. Okay, but anyways, I'm just considering that you all had checked all those things. Okay, and I'll go with this. Okay, so this principal component analysis. Okay, so there are so many dimensional reduction techniques, but this is widely used and the simplest form of all those things. Okay, so this is the very simple or the basic technique which is widely used in this dimensionality reduction. So everyone would be remembering, right? Dimensionality reduction, or within one day gap, did you guys forget? Okay, so dimension reduction is nothing but you are just reducing the number of features. Okay, why? Because either it will be like taking out of a feature, or you will be transforming the feature. Transforming the feature in the sense like from 3-dimensional to 2-dimensional. 3-dimensional, if I say like if there will be 3 features, I am just taking it as 2 features without losing the information. Okay, so now without losing the information is like the within the 3 features, I will find out the correlation or the cohesion with the relation between those things, and then I will put it up, and then I will compute it. So that is how I will be doing it without losing the information. So here in this, I mean, I had provided the link also, and in the example with the Python code, they had explained it very well that it would be easily understood. Okay, so now here in the principal component analysis. So principal component analysis is a dimensionality reduction technique that enables you to identify correlations and patterns in a data set so that it can be transformed into a data set of significantly lower dimension without loss of any important information. Okay, so you remember, right? So there are 2 types of dimensionality reduction. Anyone remembers which are the 2 types of dimensionality reduction? Is species selection and feature extraction. Okay, so this dimensionality reduction, that is PZA, comes under the feature extraction. Okay, so now here this feature extraction do is you are just transforming from the higher dimension into lower in dimension without loss of any importance or important information. Okay, so now here the step of computation of PZA. So here the main steps are like standardization of the data, computing the covariance matrix, calculating the eigenvectors and eigenvalues, reducing the dimensions of the data set. Okay, so the steps are like standardization, then you are going to find out the covariance matrix, and then you are going to find out the eigenvectors and eigenvalues, and then you are going to find out the feature vector, or you are going to find out the radius dimensions of the data set. Okay, so these are the steps. So now you are going to tell me what is standardization of the data. So this I had already explained in probably maybe in logistic regression or something I would have explained. Can anyone speak out what is standardization of the data? Can anyone speak out? Do you remember that you have heard about this standardization? No one remembers this. Okay, so I think in the logistic regression only, I think I would have said this, that feature scaling, uh, scaling would be the standardization. Remember anyone the feature scaling, standard scaler? We from the Python in the library, we took the standard scaler for scaling purpose. Anyone remembers this? At least those who had sent some two people had sent me the code. At least those who would have done it would
Ma'am,
remember.
your voice is cracking too much, ma'am.
Anyone remember what is that standard scaler and all? Okay, so now what happens is that it's like you consider a data like okay, something like I have two features. Consider two features I am having. Okay, so in that two features is that uh, like one feature is like in the numbers like 1, 2, 3, 4. Like we have the set of numbers like from varying, the range would be like 0 to 10. Consider it like that. Just imagine a feature is having 0 to 10. Now another feature is having the variable set is like lakhs or thousands to lakhs. Okay, so for my first one, when it is like number one, I'm getting having something like 1,000 or 2,000, something like that. Okay, so do you understand there is a huge difference? Okay, so here like there is so much of differences. Might be like someone is having this much of salary, like from if you are taking all the data of the complete in a full firm in the company, you are taking the data of all the salaries of everyone. Okay, so now here from the cadre, from the lower cadre to higher cadre, all the data you are having. So from the lower cadre people will be having the salary of 500,000 or something like that. Okay, I'm just telling now. It's like no lower cadre, they get so much, like it's like equivalent to everyone. So I'm not getting any examples, so I'm just telling you. So like some the lower cadre people are getting some thousand, so the higher cadre people are getting some 1 lakh. Okay, but then you are representing everyone with a like lower cadre or some higher cadre, you are representing with a number. Like we can't give it as a name, right? So some numbers you are representing which is of the range 0 to 10. Okay, but then these higher cadre people are having, so it's like from 500 to it will be varying like some 1 lakh or 2 lakhs. Okay, so now I can't have a data set like that. Okay, what will happen is if I have a data set like that, what will happen is somehow it will go into the outliers. So it we won't get the results properly because the company CEO will be having 2 lakhs or 5 lakhs. Okay, but then the other people will be having lesser. Okay, so then it will be like a huge difference will be there. Also the other feature, this is the salary is one feature, and the other feature will be like of the range which is completely different, like 0 to 10 or like 0 to 100, which is of very much less. So what I have to do is I have to do something like that. All these are in a particular thing. Okay, in a particular order, like it should be between some values which is like equivalent, not equivalent, which is of similar kind. Okay, so for that we use many standardization techniques. Okay, so here this formula is for one standardization technique. So there are mean, max, min, so many standardization techniques are there. Okay, so this is only the mean technique, so anyone we are using. Okay, so here they had just taken one formula, this usually used in most of the cases. Okay, so standardization is all about scaling our data in such a way that all the variables and their values lies in a similar range. Therefore, standardizing the data into a comparable range is very important. Standardization is carried out by separating each value in the data from a mean and dividing it by the overall deviation in the data set. Okay, so this is one kind of standardization technique. This is used most of the problems, but you have many other standardization technique also. Okay, so this is what standardization, just remember, don't forget it. So any data you have, first thing is that after the pre-processing of, you will be clearing, so you will be having blank spaces, you will be having some null values, you will be having some misplaced values, so many problems will be there in your data set. After clearing everything, and then you'll be what you'll do is, if there is like strings or something like characters or something, we can't take it out. So therefore that you have to put like 0 1, you have to either put it in the 0 1 format or some number format, you have to do it. Okay, so that is another step. And then this step is like, you have to see whether all are in the similar range, all whole data set is in similar range. If you are not, if your data set is not of similar range, then you have to go with the standardization thing. Okay, so this standardization is also a very important thing, so only then you will get a proper result. Okay, so next is that after standardization, you have to compute the covariance matrix. So already I explained what is covariance, right? Anyone remember what is covariance, correlation and all? Did you all go through that? What happened? I'm not getting any response from you today. Is it like the usual people who used to respond or not there, or anything, what it is? Okay, anyways, okay, so covariance and correlation. So the thing is that correlation is like the relationship between the variables you will be getting. Covariance, the variability you will be finding out with how both the variables, okay, if there are two variables, how both the variables are varying. Okay, so that is some then correlation, it is like the range would be like from -1 to 1, and in covariance the range is from -infinity to infinity. Okay, so these are the some of the differences of the main differences of the correlation and covariation. But then usually both are like, both are interlinked, and both are so in place of correlation people say covariance, in place of covariance people say correlation. It's like, because the thing is similar, the relationship is the main thing. Both are like, we are like finding out the relationship. Only the thing is that a little bit of variance is there. This here covariance is like the both, how much it is, the relationship is varying, like in both together how much is varying. But in correlation it's not like the between them, it's what is the variation or relation. Okay, so that is what the main thing is. So it is like interchangeably used, both these terminologies are interchangeably used. Though it is like similar, there is some difference is there. So uh, quite a different is that. So that even like when it's like when you come into the deeper problems and also, that time the difference will be seen, but otherwise it will be like sounding the same thing. Okay, so now here the aim of the step is to understand how the variables of the input data set are varying from the mean with respect to each other, or in other words, it's to see if there is any relationship between them. because sometimes variables are highly correlated in such a way that they contain redundant information. So in order to identify these correlations, we compute covariance matrix. Okay. So now to identify the correlations or the relations, we are finding covariance matrix. So mathematically, so if there is a covariance matrix of P cross P matrix, so where P represents the dimensions of the data, each entry in the matrix represents the covariance of the corresponding variables. So can anyone say this matrix is of how many dimensions? I told you all to go through this covariance matrix and everything. Can anyone say that this matrix of how many dimensions?
I'm three.
Okay, so this dimension is of three. This covariance matrix is of three. Okay, so here we are having three dimensions: x, y, and z. So that is why we are having three columns and three rows. Okay, so it is this covariance matrix. It's usually it's a square matrix that means it's P cross P. Okay, the number of rows will be equal to number of columns. So here we are having three dimensions. Okay, see. So now here this is the difference. So now here covariance, first thing is covariance of x comma x. Okay, the how it is the relationship between these two variables. Next is like x comma y. The covariance of x comma y gives you the relationship between x and y. Okay, so how it is changing from the mean. Okay, how it is varying. Okay, these both variables, how it is changing. Okay, so similarly, so this is for a three dimension. Okay, so you will be having with n dimension, and you will find out the covariance matrix. Okay, since the covariance matrix of the variable itself is its variance, that is, I mean, if it is like a comma a is equal to variance a in the main diagonal, top left and bottom, we actually have the variance of each initial variable. And since the covariance is commutative, the entries of the covariance matrix are symmetric with respect to the main diagonal, which means that the upper and the lower triangular portions are equal. So the upper and lower, in the sense, this is a diagonal. Okay, so that is covariance x comma is x y comma y. Sorry. Here, this is the diagonal x comma x and y comma y and z comma z. This is the diagonal. Okay, so now here this upper thing and this lower thing would be proportional. Okay, because I mean these portions would be equal. Okay, these both triangular, upper triangular thing and the lower triangle will be equal. So here this covariance thing, why it matters is the actual thing which matters is that sign. So if it is positive, then the two variables increase or decrease together. Okay, if it is negative, then one increases, the other decreases. Okay, the positive means that is direct proportionality, negative means inverse proportionality, that is one increases, other decreases, and one decreases, the other increases. Okay, so here what from the with these values, what we are going to find is that from the sign here in the covariance, from the sign we are going to get to know what is the relationship, is a proportional relationship or inversely proportional relationship. Okay, so is both the variables are varying together, or like you have the interchange, like decrease means increase and increase means decrease. That is what the main thing we are going to find out from the covariance matrix. Okay, so the next step is to compute the eigenvectors and eigenvalues. Okay, so this eigenvectors and eigenvalues are the linear algebra concepts that we need to compute from the covariance matrix in order to determine the principal components of the data. Okay, so we are computing this eigenvectors and eigenvalues because to determine, so eigenvectors and eigenvalues are nothing but the principal components. So only for determining that we are finding out this eigenvectors and eigenvalues. Mathematically, we are calling that as eigen, and here in machine learning we are calling it as principal components. So this principal components are new variable that are constructed at linear combination or mixtures of the initial variables. So initial some variables will be there. So from that we are transforming. So from the initial thing we are just transforming to new variables. It could be like mixtures or combinations of the initial values. So the 10 dimensional data gives you a 10 principal components, but PCA tries to put maximum possible information in the first component, then maximum remaining information in the second, and so on. Did you get what does that mean? Anyone? Did you get what it means? I told you that we are doing this PCA for dimensional reduction. Okay, and this we are finding out the eigenvectors or eigenvalues for finding out the principal components. Okay, so now principal components are that which should be the reduced form, right? Because the thing we are learning is PCA, that is principal component analysis. Now here they are saying 10 dimensional data gives you 10 principal components. Okay, so now where is the reduction? How am I going to reduce it? Anyone try out, yeah? Someone speak. Why today nobody is speaking? All you guys are tired or what? No one is speaking. Okay, so I'll say, so now here what happens is we are taking the maximum information. Okay, so now the first principal components, if I want, like if I'm take from the 10 dimensional, if I the 10 dimension I'm going to reduce as 5 dimension, that is 10 features I'm going to reduce as 5 features. What I will do is the first 5, okay, the first 5, the maximum 5 principal components I'll take. That is how I am going to reduce. But then how many ever features I am having, that many principal components I can get it. But I take the starting. Okay, if it is like 2 dimension I take, only the starting 2 I take. Okay, so depending upon how much my loss is there, I compute and I'll take it. Okay, so now organizing information in principal component this way will allow you to reduce dimensionality without losing much information, and this by discarding the components with low information and considering the remaining components as your new variables. Okay, so the lower information, that is the lower PCAs I am taking as I am discarding, and the higher PC, that is principal components, I am retaining it and I am taking as my new variables. Okay, so this is like here the principal components. This is how I will be getting the principal components. Now if I want the first 2 alone, I'll take only the first 2. I'll discard the rest of the things. Depending upon how much information I am losing, that value I'll check and I'll just discard it. Okay, every eigenvector has an eigenvalue and this number is equal to the number of dimensions of the data. Okay, so it's the same thing, like 10 dimensional means you will be getting 10. Okay, so all the this eigenvector and eigenvalue comes together. Always whenever you see it, it comes together. So now here, if there are 3-dimensional data set, then there are 3 variables, that is like 3 eigenvectors and corresponding 3 eigenvalues will be there. So this eigenvalues on the other hand simply denote the scalars of the respective eigenvectors. Therefore, eigenvectors and eigenvalues will compute the principal components of the data set. So this is like the how you denote the eigenvector and eigenvalue. So any matrix. Now I have a matrix A. Okay, this is what I have to transform into. So for transforming, what I am going to do is, like, this is my eigenvector, this B is the eigenvector, and this like lambda is the eigenvalue. Usually your eigenvalue is represented with lambda. So this both will be equal. So like my transformation, the matrix which I have wanted to transform, that into eigenvector will be equal to the eigenvalue into eigenvector. Okay, so this is the formula for the basic formula for the eigen, the relationship between the eigenvector and the eigenvalue. So this eigenvector and eigenvalue always go together. So every eigenvector will have an eigenvalue. Okay, so now next is the feature vector. Feature vector is nothing but we are going to reduce the components. Okay, in the previous step, computing the eigenvectors and ordering them by their eigenvalues in descending order allows us to find the principal components in order of significance. Okay, so you will be finding it, all the eigenvalues, and then you will arrange it in the descending order. Okay, I'm saying eigenvalues is same as the principal components. So the principal components I'll find and I'll arrange it in this descending order. In this step, what we do is to choose whether to keep all these components or discard those of lesser significance and form with the remaining ones a matrix of vectors that we call as feature vector. Okay, so to discard those as lesser significance and keep the remaining is what we call it as feature vectors. This is the step. Okay, so the feature vector is simply a matrix that has columns, has as columns the eigenvectors of the components that we decide to keep. This makes it a first step towards dimensionality reduction, because if we choose to keep only p eigenvectors out of n, the final data set will have only p dimensions. Okay, so when we from the, that is like from 10, if I'm choosing 5 principal components or the eigenvectors, I'm going to have my matrix with p dimension or 5 dimensions. So this thing is called feature vectors. After finding out all the principal components or all the eigenvectors, and then I'm going to decide which all I am going to keep it. So whatever I am going to keep it, so that is the feature vector. Okay, so this is like almost like the final step. Now next step is the final step, where we are going to compute, that is where we are going to transform. So here we are recasting the data along the principal component axis. In the previous steps, apart from standardization, you do not make any changes on the data. So you remember standardization, right? So standardization, and like it will be always coming over in your machine learning. Please don't forget, standardization is what you will be having. You will set your data in a particular range. Okay, so there won't be like very lesser and very high thing. You will set the data such that you will be having a particular range. I already explained in, I guess, in logistic regression or something, I have explained, and I remember I explained all these things to you. Okay, so now here you do not make any changes on it. You just select the principal components and form the feature vector. Okay, so you remember the name feature vector, right? That is your previous step where you have arranged in the descending order, and then you had neglected whatever is not necessary. But the input data set remains always in terms of the original axis, that is in terms of initial variables. So, but then input, whatever first thing is you have is still over there without any change apart from the standardization. You only got the principal components now. Okay, principal components you got, and then you have made a feature vector, that in the sense you have neglected whatever is not necessary. So in this step, which is the last one, the aim is to use the feature vector formed using the eigenvectors of the covariance matrix to reorient the data from the original axis to the ones represented by the principal components. Hence the name principal component analysis. This can be done by multiplying the transpose of the original data set by the transpose of the feature vector. Okay, so you are coming to the final data set. So in the final data set, what you do is you multiply the transpose of feature vector into the transpose of standardized original data set. Okay, so that is how I am going to get, that is how I'm going to get my final data set. Okay, getting my point. So now here it will be of reduced thing, because first you had so many dimension. First, if I have 5 dimension, now it will be like I'll be having some, sorry, for the 5 dimension is means for now I'll be having some 2 dimension, or from 3 dimension to 2 dimension, something like that I'll be having. So this is how it is. Principal component analysis. Did you all get it? Did you got some idea over how this principal component is done? Okay. So now next we'll go to the Python thing. So here first, as we do, like you will import the pandas, you will import, okay, all that is number unnecessary numpy and everything. So here in this you have, I mean, I had given the link, okay, in the presentation itself. I'll be sending this PPT. Just go with the link, okay. So there all the explanation is given, as well as you can with the data also you can download, okay. So the URL also they had given, okay, data you can download and you can try it out, okay. And you try it out and send it to me. So like, because I have my exams probably this weekend if possible, or by next weekend I will send you back all the whatever mails I got from only 2 people. I have got it. If anyone else also want to send, no, just send it to me. I will just reply within this next week, okay. So now here next is like we are loading, okay. So we are this here from this URL we are just taking these names, okay. Here in this you can actually take directly also, or you can take this way also, okay. So there are so many ways to do it. So here they are following this way, okay. Like previous examples you would have directly read for the URL, like that also you can do it, okay. So here you have these as a columns, they had put this one, okay. So now next is when we are importing the standard scaler, okay. So this is what I was telling, the feature scaling or the standardization, all these things, okay. So this is why we are using the standard scaler. So in order to get a standard, okay. So here now here these are the features, sepal and sepal width, all these are the features. Now we are separating the features because we need x and y, okay. X and y we need this. So here in x we are storing this features, and in y we are having the target. Now next we are going to do the standardization. So now here I have the standard scaler. So when I apply this command, no, what happens, everything will be scaled, okay. So now here you see the sepal length, sepal width, petal length and petal width. Almost this is a similar, but then still they have standardized. So okay, so that we are getting these as a standardized thing, okay. So this is like from the range -1 to 1. Here if you see like 5, 4, 3, all these are given. Here it is a range will be like -1 to 1. A standard range is there, okay. So that is why they are doing this standardization. But or in this particular problem you can try it out without standardization also. Mostly you'll be getting it because there isn't so much of difference. But in some cases you will be having so much difference that you can't do that way, okay. You have to do standardization at any case, okay. So now here next is like, now I am I am importing my PZF. So whatever it is, like anything, now here I just want you to go through all this covariance, eigenvector, eigenvalue, because it's like you would know in depth, okay. So but still, I mean, even if you're not going through in depth, if you know to just put the coding, just if you know that this is how, if you know it, this is how the procedure is this, I am having a data set. Now if you have the idea how what I should do with the data set, so I'm seeing the data set. So then I will see whether it is supervised or unsupervised, that is whether I'm having all the details or not. When I'm if I'm having no details, like if I'm not getting more details, like what I have to do with the independent variables or dependent variables, I'm just even thrown out with some data which is of like any variation. I can only do the clustering. If I have proper data with like a target or and everything, so then I have to choose whether I have to do the classification or regression. So if at all you are able to find that particular thing, okay, so then you are like you had come to the position where you can work with the projects. Okay, so then because then the thing for the coding is that most of the codings you can download, you can directly get it from the net itself. Okay, so just you type like PZA how to code. Okay, you will be getting the course. Then you can just type it out. Okay, so the initial thing of the Python, the little of Python, the basics, if you know, then everything else you can do it easily. Okay, because everything is now freely available. Okay, so now here for anything, for everything will be important. So Python is like full of libraries. Okay, so for you should know from which library you have to get it. So just take it learn from here. You are going to import the PZA. So now it's if you're switch off your microphone. Wait, I mean maybe hopefully now it should be okay. I think. I mean microphone. I'm not using anything else directly.
No, ma'am, yours is perfect.
Uh,
Pratyusha ma'am's microphone is
so
on.
if I mean if I'm the only the audio thing I'm using, if I just stop that, like nothing will be heard. Okay, so now here, this PZA, I am just choosing two. That means I am going to have two components, dimensions. That is how I am going to do it. So now the principal components I am going to transform. This in transform PZA.fit transform is where I have to transform, and then I am going to save it in the principal components. Okay, then this principal this principal data frame is where I am having this data frame with the principal component 1 and the principal component 2. So when I do this, like when I transform this is my set, I mean initial thing where I have all the variables in a standardized form. Now I have applied this PZA. Okay, so when I apply my PZA, I have got into two dimension, like the principal component 1 and principal component 2. As I said, I will be having so many principal components, but here I am choosing two. I am choosing the first two. That is the highest thing I am choosing. Okay, that is why I am getting here as two. Otherwise, you will be getting all the principal components. If I haven't chosen this, I will be getting all the principal components. Okay. So now here you have chosen two. So now what I have to do, this final thing will be like I have to concat it. Okay, so this is PD concat to this principal DF, then DF of target. Okay, so here I am concating it. So here when I concat it, I am getting this. So here this principal component, and this is a target. This is the final DF I have. Okay, this is the part where the principal component ends. Okay, so next is what you will do is after this you will be doing some linear regression or anything, and then you will be getting the output. Okay, so you can try it out with different like now here principal component is 2 you have taken. Now you can take it with 3 or something. No, then you will do some other algorithms. This is for just the reduction purpose. Okay, from the main thing you have reduced it into two components. You had here some 5, I guess. Okay, 4. From 4 you have reduced to 2. Okay, so next you will be using some algorithms where I mean logistic regression or anything. After this you will be using it. Okay, so here you have the link. So this link, all of you go through it. So here the step by step they have explained this code very clearly, so you can you do it, and also the data also you can download from there, so it will be easier for you. So they have done with the logistic or linear regression also. The next part also they have done it. You can try that also. After this they have implemented with the logistic or linear. Okay, so everybody is clear with this, the principal component analysis and the dimensionality reduction. Say something. Yes, no. I mean, today the class is too quiet. Okay, so just remember this dimensional reduction. We have so many algorithms in that. One thing is that principal component analysis, where you will compute the principal components. Components in the sense you are just computing a covariance matrix, and from that you are computing the eigenvectors and eigenvalues, the highest eigen. Then you are going to put it in a decreasing order, because we are going to take only the highest. Okay, because that is what you are going to have the maximum information. So if I want to have two, I'll just take the first two. If I want to have three, I'll just take the first three in the descending order. Okay, so then afterwards I will do the after that I'll be having a set of things with the reduced form from 5 to 2 or 5 to 3, how much ever one. Or this will be like you will be having features, or some hundreds of features you'll be having, so you will have to reduce it as much as possible. So in one way it is like in machine learning. So whenever you do machine learning, you want so many features and so many like variable set. Okay, so the data set should be huge, so that it will be you will get more accurate in one sense. But then still sometimes it will be like overfitting, it will be like too much for the algorithm or the machine to work out. So and sometimes you will be having the base information in the data set. So for that only we are doing all these things, so that you will get some accurate thing, and then you can use it, so that the what you get it, the value would be higher. Okay, so that is why you are using this principal component analysis. So this is one main thing. So here you have learned already supervised, unsupervised, and everything. Okay, so this is used for in all those things. Okay, so mainly it will be used for the classification and all. So it will be used for the reduction. Okay, so just remember that. And here, like if you are non background, if you don't have any background of maths, then it's okay, like you can code it. When if you know what to be done, you can code it. But then it's good to have some idea about this eigenvectors, eigenvalues, this matrix computation, what is transfers. Okay, so from columns to rows, rows to column, all these things. Okay, so like if you if you have this like simple mathematical things, no, you should know. Okay, that will be like it will be good for you. So you will know what it is exactly. Most of you would have studied the matrix and all those stuffs. Now here is why we have studied all those things, is like we are using. So this is why, like when you would have studied all this matrix and everything, when you are studying in 10th or 12th, you would have not understood why all these things are right. Why when you are studying this linear algebra, you would have simply found out what is x. So this is how it becomes. So here also in everything you will be like finding out something, you will be predicting what the value could be. So that was where your foundation is. And then now we had come to this. In machine learning also, the machine is doing all those steps for you. So if you have little knowledge of Python, you can easily code it and get it. Still it is good for you to know the basic mathematical formulations and how it's done, all this. So when you get time, you go through it. And some of you, if you get time, any time in the weekend, just go through the YouTube also, which Kaniga ma'am or someone had provided, right? So that also you try to go through. I have covered everything, but still if there is anything, you can just go through and inform me, so that it will be like anything is there, we can discuss. Okay, so now that's all for today. You can leave. Thank you. You have anything to ask?